This is the lecture on Plato's Phaedo. Plato's Phaedo is in many ways Plato's attempt at defending and articulating what he thinks to be the central tenets of Pythagoreanism. That's why I had you listen to the podcast that I made about Pythagoreanism, so that you know where it came from, what motivates it, and why people were compelled to think that it was true back then, maybe even today. The Phaedo tries to add to Pythagoreanism all of those things that Plato believes must be true in order for the tenets of Pythagoreanism to be true. The view that the soul is immortal and transmigrates from the body to a heavenly realm and back. That's a view that many religions have. But as a philosopher, Plato is trying to give what he takes to be knockdown arguments as to why that has to be true. It's a very ambitious feat, and you may not think that Plato succeeds. In fact, very few people do. But just because a philosopher isn't successful at arguing for something ambitious doesn't mean we have nothing to learn from how they try to argue for it. Pythagoreanism, as you've heard in the podcast, begins with the observation that mathematical knowledge is particularly impressive. In addition to how impressive it is, it's also true that when we look carefully at nature, mathematical objects seem to be perfect descriptions of what's going on. They're perfect descriptions of imperfect phenomena. For instance, the notes of a musical scale, and so forth. Given that you've listened to the podcast and know some of the things that motivated Plato, let's go to the Phaedo and today examine one particular kind of argument for the immortality of the soul that Plato gives. In the next lecture, we're going to look at the other kinds of arguments that Plato gives. This lecture will focus on the immortality of the soul as suggested by human knowledge of mathematics. Plato reveals himself to have a series of commitments in the Phaedo that are finally made explicit. They were implicit already in the Euthyphro, Apology, and Crito. Perhaps the most important commitment that is laid out explicitly in the Phaedo is that everything we correctly assign to a category must have something in common that makes them members of that category. For instance, we call things of a lot of different colors and shapes apples. What makes them all apples, even though some are green, some are yellow, some are red, and different shades of red? Whatever it is that all apples have in common that make them apples, Plato calls the form. The form is whatever something has in common with another that makes them two things that we call under the same name. Yellow. Many different things of different shapes and functions are yellow. What do all of those things have in common that make them fall under the category of yellow? That Plato calls the form. This is precisely what he was after in the Euthyphro and in the Crito. All of the things that we call pious or impious must be called those different things for the same reason. They must have something in common. Formulating what that thing they have in common for Plato is formulating the form. What makes all people people and not something else? It's the form. Justice. All of the just things under one category and all of the unjust things that fall into another category must have something in common. We might not know exactly which things fall under justice, but we know that whatever does must have one thing in common. That's the first commitment. The second two, Plato explicitly argues for in the Phaedo. There's a view that he has, which I will demonstrate in a second, that almost anyone can come to know the form of mathematical and geometric objects with only questioning. You don't need an education, and you don't need to look out and inspect the world to know facts about numbers and geometrical facts. This is a commitment he acquires from Pythagoreanism. The Pythagoreans, and Pythagoras being the person who was credited with discovering the Pythagorean theorem, were the ones who showed the ancient Greeks just how impressive mathematical and geometric knowledge can be. That impressiveness is in contrast to how unimpressive empirical knowledge can be. Is the thing in the distance a sheep or a rock? That kind of knowledge is never as certain for Plato as knowledge that a squared plus b squared equals c squared. Given how imperfect the observable world is, the view is that it cannot give us knowledge of the form of mathematical and geometric objects, what all triangles have in common that makes them triangles. You can't gain that knowledge from looking at different things that are triangle in shape. Because in the observable world, there are no perfect triangles, no perfect numbers. And as Hippasus demonstrated earlier, there are no irrational numbers in the observable world. And yet we can prove that they exist. So how does Plato, unlike the Pythagoreans, try to argue with absolute certainty that these commitments are true? There's a dialogue that demonstrates this quite well. It's the Meno. It's actually in the book, but we're not going to do that dialogue in this class. And Plato hints at this in the Phaedo as well. I might as well show you what the reasoning looks like there. This is Plato's attempt to demonstrate that uneducated souls who have never taken math, geometry, or anything of the kind can just think very hard, and answering only questions, come to know something absolutely certain about geometry. Start with a square. You start with the question, what happens when you cut the square in half diagonally? That's the question. The answer that Socrates thinks any person who is looking and paying attention will answer that question is that you'll get two triangles, each half as big as the square. That's not something somebody had to be taught. That's something that anyone who's thinking about it will come to know. Next, what happens when you add 3 more squares of the same size to the original one in this way? That's only a question. And Socrates believes that anybody who's just paying attention will know how to answer that. You're going to get a new square that's 4 times bigger than the original. Next, what happens if you cut each of those new squares the same way that you cut the first one? And Socrates thinks that anybody paying attention, even without any training in math, will know to answer that you're going to get yet another new square. And that square will be exactly half the size of the big square and double the size of the original small square. That's really easy for them to know because all they have to do is count up the triangles. The little square has 2 in them. The diagonal square has 4, and the big square has 8. And now, all we have to do is label the original square, call it ABCD. And we can express this new knowledge That knowledge is segment BD squared is equal to twice AB times AD. AB times AD is the area of the square. Twice that area is the area of the square of BD. This bit of knowledge can also be expressed as the Pythagorean theorem. If we just label the sides of the triangle as AB and the hypotenuse as C, we've just learned a squared plus b squared equals c squared just by answering questions. That demonstration that you'll find in the Meno is supposed to show that everyone who just pays attention already knows the Pythagorean theorem. The questions are there to reveal what people know. It's not there to give people new knowledge. The next observation that Socrates makes in the Phaedo is that the observable world and the senses itself can't be the things that gives us this knowledge of the form of mathematical and geometric objects. And why does he think that? And you might think, well, it's because teachers told me about this. That's how I know. That's from the observable world. And it's from the fact that I had a drawing in front of me. That's how I know. It's not because I had that knowledge first and I just remembered it, as Socrates seems to be arguing. Well, the response is that you may have heard about the Pythagorean theorem from your teacher. You may have learned about it. You may have seen how it worked by looking at drawings. But you didn't know it to be true from the fact that your teacher told you about it. You only knew it to be true when you figured it out yourself. You only knew it to be true when you thought about it and were able to answer these questions. Figuring things out yourself in this way is the source of mathematical knowledge. That's how you know something. You have to have done the reasoning itself. You have to have answered the questions. What you didn't have to do was inspect a visible object or accepted your teacher's testimony on it. Just accepting from your teacher that a squared plus b squared equals c squared isn't a way of knowing the Pythagorean theorem. But having followed along the diagram and answered the question is a way of knowing the Pythagorean theorem. And then as far as the drawing itself, if you think about it, that drawing is an imperfect drawing. You don't know on the basis of an imperfect drawing. Instead, you're using the drawing to think about the perfect thing. The drawing is actually not all that necessary. If really you were knowing about the Pythagorean theorem on the basis of the drawing, you would have taken out a ruler and measured the squares and measured the triangles to get the relationships. Not only did you not do that, you didn't feel the need, and it would have been quite ridiculous for you to go and find a ruler to find out the truth about the mathematical theorem. Rather, the drawing is not how you know it. It's a tool for you to think about it, but the thinking about it itself and the reasoning through is the source of the knowledge. So, the problem as it's posed in the Meno is, how is it that people can have known the Pythagorean theorem, but couldn't tell you what it was, but with the right questions can tell you what it was. Well, according to Socrates in the Phaedo, the only thing that works this way is recollection. Recollection or remembering is having something come to mind that you've forgotten. In order to recollect a man, you must have forgotten the man. But in order to have forgotten, you must have first known the man. And so the reasoning goes, it must be that with mathematical facts, geometrical facts, you actually did know how to answer that question because you knew the answer. You weren't able to give it beforehand because you forgot. And now that you have it, you might forget again in the future, only to be brought back to its truth, to your knowledge of it, with the right questions again. That argument from recollection, Plato takes to be a very good argument for the immortality of the soul. How else could any individual human soul know that the Pythagoreanism is true if it doesn't know it from the observable world? Well, it must be that the soul encountered these mathematical forms, these mathematical truths, in an invisible other world. And so the soul must be immortal, and when it leaves the body and the observable world, must inhabit this world where it's once again with the forms. And finally, there is this series of arguments about judgments in an imperfect world. The observable world being constantly changing, being imperfect in the sense that there are no perfect geometrical objects, and there are no perfect duplicates so that you can count two things. The problem that Socrates poses in the Phaedo is, how could that be that we make judgments using mathematical concepts like equality, greater than, less than, 1, 2, 3, 4, 5, when all the things in the observable world are imperfect? Take the example he gives, equality. There are an equal amount of forks and knives on this table. The bill today is equal to the bill yesterday. These two tables have equal length, but they are both unequal or unequal to this other table. Socrates thinks those are pretty sound judgments. But how could we possibly make them when no two forks are exactly the same? No two knives are exactly the same. No two tables really have equal lengths. When these are inexact things in the world, we still impose on them perfect mathematical concepts. No two forks are the same, but we're still going to count them as two. No two knives are the same, but we're still going to count them as two, so that we can say there are equal number of forks and knives on the table. The view is that we're deploying a concept that's perfect into things that are imperfect. There aren't really two forks and two knives, because there aren't really two of anything. Everything in the observable world is actually different. Nothing is actually equal to anything else in the observable world. And yet we do impose equality in the observable world. How is that possible? Well, it has to be that we didn't get the concept of equality, the concept of two things, three things, four things, or equal length from looking at the world. Because if we did, we would have never come to have that concept in the first place. We would have never had the concept two forks, because we would have never been able to see two of the exact same thing. And yet we do impose on the world these perfect concepts from math. It has to be because we have those perfect concepts, not from looking at the observable world, but from where the soul was before it inhabited the observable world. Next, we make judgments all the of mathematical perfection in an imperfect world. We do this with triangles. That is triangular. That is unjust. That is impious. If all we ever did was inhabit a world that was observable, we wouldn't be able to use those judgments at all, because we've never encountered perfect justice. We've never encountered perfect piety, and we've never encountered perfect triangles. If we've never encountered perfect of those, why would we ever say of a world that it's unjust, that this is not really a triangle, it's a little bit like a triangle, or that this society is better than this other society? Plato thinks that the only explanation you can give is that we are comparing the observable world to an ideal world, a world of perfect justice, perfect piety, perfect triangularity, that world of which we know we've just forgotten. We're applying a forgotten concept to make comparisons between our imperfect world and the perfect one. That's the only source of our judgments, Plato thinks, to make sense of how we can recognize injustice when we recognize it, because of our prior sense of justice that we get from the perfect world that our souls inhabit. This kind of argument is half of the kind of argument that Plato uses in the Phaedo to argue for the immortality of the soul. I'm going to leave this part of the lecture with the discussion questions I want you to write about and then bring to class. Those questions are: after listening to the podcast episode and reading through much of the Phaedo, what do you make of the idea that mathematical knowledge forces us to seriously consider that our souls must at some time inhabit some invisible, abstract, perfect realm consisting of triangles, circles, justice, and the forms? And finally, as mystical and abstract as is the view, and you probably don't believe it, but setting belief aside, philosophy class is not to get you to believe anything. The question is, what do you think is compelling, insightful, or attractive about the views that Plato is arguing for in the Phaedo? What aspect of it seems true, and why? In our next lecture, we're going to look at the more metaphysical arguments that Plato gives for the immortality of the soul.